let's say the mod cluster configuration for Apache. This is the most advanced proxy plugin available between Apache server and the JBoss app server. A mod cluster majorly provides these three additional advantages over and above the mod JK. We have already seen mod JK. Mod JK provides a static cluster, which means the JBoss app servers that are attached to a mod JK module are static in nature. Means if you want to add an additional server, we have to shut down everything, then only add an additional server. The same way, if we have to remove something, so we have to shut down everything, then only we can remove it. Whereas mod cluster, the most striking difference between a mod JK and mod cluster is dynamic cluster availability. Means on the JBoss side, members or JBoss instances can be added dynamically. Means you can start a JBoss server and it automatically gets added to the cluster, which means the mod cluster plugin on the Apache server automatically detects the newly added server and it starts to load balance the request even to the newly added server. We will see that in implementation in a moment, how a dynamic server actually functions in real time. And the next difference is with the HTTP support. The mod JK supports only AJP 1.3 between Apache and what we say, the JBoss. Whereas here, so if you have, let's say this is Apache server and this is a proxy plugin, the JBoss instances on the right side will be listening on the AJP port. Here we know the AJP port is 8099 and here also AJP port is 8009. So here between mod JK and the JBoss, it has to be always the AJP protocol only. Whereas if it is a mod cluster, alright, if you are using mod cluster plugin, then it supports both AJP and HTTP also. But we know that AJP is more efficient than HTTP. So even though mod cluster supports both AJP and HTTP, we still be using AJP only to load balance the request. The HTTP protocol will be used for some other purposes. We will see that what the purpose is. Then there is a third and more striking difference between mod JK and mod cluster is the way the proxy plugin load balances the request. Now normally any load balancing is popularly done by the round robin mechanism, which means request 1 goes here to the first server, request 2 goes to the second server, 3 goes to the again first server here, request 4 goes to the second server here, then 5 here, then 6 here. That's a equal distribution. Now let's say like this it happened. Now assume once a request lands on this server, it may happen that these 3 requests take longer to finish than these 3 requests. It can happen, right? So there may be a session which is existing for a longer time. The user may be working really hard. So assume the first instance, the sessions are taking, it took 10 minutes for them to complete, whereas these things, they're just finished in probably, let's say, 5 minutes itself. Now obviously after 5 minutes the second server has less load than the first JBoss server, but the mod JK cannot realize that. It simply distributes the requests based on not of the load of the JBoss but the number of requests that are sent. The mod JK has no way to know whether the requests have finished or if they are still in progress. So after 5 minutes of time, if you check both these JBoss servers, the first instance still has 3 requests on it whereas the second JBoss instance has no requests in it. Let's say again, then some more requests came into mod JK. Let's say up to 6 now. Let's say 7, 8, 9, 10, 11, 12 requests came in. So the mod JK simply distributes the load here. So after 5th minute, the load distribution will be like this. So request 7 here, request, okay, just a minute. So request 7 here goes in, request 8 goes in here, request 9 goes in here, request 10 goes in here. So this is happening, and again here request 11 goes in here, request 12 goes in here. So let's say these 6 requests arrived on 6th second. So if you look at the load at 6th second, if you take it on a timeline, all right, let's look at, all right, this is, let's say this is a 5 minutes or 5 minutes, this thing, 5 minutes march, let's say. So at 5th minute, JBoss instance 1 has only 3 requests, whereas JBoss instance 2 has no requests at all. At 6th minute, assume the request landed. So the JBoss instance at 6th minute, JBoss instance 1 at 6th minute has 6 requests, means the first 3 requests are taking 10 minutes. So this has 6 requests, isn't it? So whereas instance 2 has only 3 newly incoming requests, which means the load is not equally distributed. Actually, the mod JK thinks that the load is getting distributed, but the actual load on the JBoss instances is not even. That is what is fixed in mod cluster. Means the mod cluster has the capacity to get the actual number of requests running on the individual instances, thereby distribute the load according to the actual load on the JBoss servers. It depends on a factor called business. So each JBoss instance will have a calculated number called business, and depending on the business of the JBoss instances, the mod cluster distributes the load. It does not follow a simple round robin. A round robin is a pretty blind one. Means it does not take into account how much each of those requests are taking on the destination. Some requests may take 1 minute, other requests may take 10 minutes, but a round robin algorithm simply looks at both of those requests as equal load, but in reality they are not equal load. Request 1 is taking 1 minute, request 2 is taking 10 minutes, whereas mod cluster can detect the business, which means request 1 is, or the server holding request 1 is busy for 1 minute, whereas the server handling request 2 is busy for 10 minutes. So the next request will actually go to server on 1 only till the business factor becomes equal. So mod cluster, it's not just about dynamic cluster, it also about the distribution of the load. So we will see that one in a while, but what we are actually talking is mod cluster is much better than mod JK. Alright, so let's go ahead and try to set up the mod cluster. Mod cluster setup. Let's go ahead and set it up. Now these are some of the differences as we have already talked about it. The major differences is obviously static cluster versus dynamic cluster, then round robin based load balancing versus load factor based load balancing. And there's another thing here, the difference. It may happen that, and obviously this let's look at this one. So AZP 1.3 support, whereas this supports both AZP 1.3, HTTP and HTTPS also. What we may not know probably is this one. So this one. If the app is down on JBoss, mod JK will still send the request. Now, what we are actually talking here is the JBoss instance is up, but the application deployed on the JBoss instance for some reason is not functional. Means the app is down. The JBoss instance is up. Means when you do a ps-ef and grep for Java, you will actually see the JBoss instance here. But it does not mean that the application is accessible on it. For some reason, the app is down. That situation, the mod JK cannot realize the failure of the application. It will still send the request to the JBoss server. Whereas okay, so sorry about that. So the mod JK cannot realize the application being down. It will still continue to send it, in which case JBoss server will simply tell the application on my JVM is not running, so the request will fail. Whereas if it is mod cluster not only knows about the JBoss instance status, but it can actually identify the application status also on that instance. If the application on that instance is down, the mod cluster will stop sending the request. Alright, so mod cluster in a way is much more intelligent than mod JK. So it basically takes care of requests if the load on the JBoss server is high, if the application on the JBoss is non-functional, if extra additional JBoss instances are added to the cluster, it can detect all of them and it can efficiently balance the load across the JBoss destinations. So mod cluster is the most advanced proxy plugin probably in the market. Now what you are about to see is the architecture of the mod cluster. The mod cluster has a very complex architecture. It's a very nice one. Let's try to see what this architecture is. I'm going to take one piece at a time. Alright, this is the final architecture what you are looking at. I'm going to start from the left side of it and slowly move on to the right side and see what are the various components. We'll try to explain each one of them. Now these are the 5 diagrams that will actually result in the last picture. I'll start at the first one. This is the left side of usual diagram that we have. The Apache server. The Apache server is that we have installed already. Now earlier we have configured the mod cluster. Now instead of, mod JK is what we have configured. If we want to stop the mod JK, then configure mod cluster. We will still use the same Apache server, but instead of mod JK, we'll configure mod cluster. Now let's see the architecture of mod cluster. It's very rare that even a proxy plugin has an architecture. This is the nice thing about it. A mod cluster has 3 individual elements to it. Assume they are 3 individual channels. They are called I've marked it like, people. So there is one person called advertisement channel. There's another person called load balancing channel. There's another person called management channel. Now each of these channels have an independent job, and we always know a channel is nothing but a socket. So when you set up mod cluster with Apache server, the Apache will have to listen on multiple channels. Now in this case, technically 3 channels are required, which means the Apache should have 3 sockets. In reality, the load balancing channel and the management channel will be same. Uh, Management channel is different. The advertisement channel and load balancing channel is will be same. Usually what happens is we don't access the advertisement channel. The advertisement channel is internal channel, so nobody accesses it, so we don't have to really use this one. So okay, I'll talk about those things anyway. So assume the mod cluster internally has 3 channels in it, each channel represented by a figure here, a human figure. Now the job of each one of these channels is different. The main job of balancing the load is obviously from the load balancing channel. The other 2 channels also have very important functionality. Let's go ahead and see what they are. This is the second figure. Now on the right side we have, let's say, a JBoss cluster setup. The JBoss cluster again is same, which means there are 2 JBoss instances started with your again you have this infinite span here, infinite span here, J groups here, the same stuff, right? So these 2 have now the capability of replicating the HTTP session. What we are trying to do is set up the load balancing to these 2 servers using the mod cluster. Now if you go further, this is the third diagram. Now what usually happens is the mod cluster has 3 guys: the advertisement channel, the load balancing channel, and the management channel. So here you have this guy, you have load balancing channel, then you have management channel. Alright. Now when we started the JBoss instances, obviously we have started using the HA profile, which means the J groups is already available and the J groups are on this IP port. So the multicast address for J groups is 224.0.1.105, which means instance 1 and instance 2 are actually multicasting on this IP. Now when you start the JBoss instance with a HA profile, the HA profile also has a mod cluster element already included in it. I'll show you the mod cluster element inside the HA. So the mod cluster part of JBoss is already there in it. So instance 1 and instance 2 are multicasting to the multicast address. Now on the mod cluster side of Apache, the advertisement channel actually talks to the same multicast address. Means the mod cluster keeps telling these members about the load balancer and about the management channel. Now let's see why it's required. Assume advertisement channel is one guy who advertises it. Let's say he keeps shouting in a mic. He says that there is a load balancing channel running at this IP port. There is a management channel running at this IP port. It will basically tell about the IP port of load balancing, IP port of management channel. Now all that being advertised is advertised on the multicast address of the cluster, which means anybody who listens on this multicast address can identify where the load balancing channel is and where the management channel is. Management channel is the guy who collects all the information. Basically, it knows which cluster member is available, which cluster member is not available, which application is available, which application is not available, all those things. So anybody who wants to join a cluster simply has to contact the management channel. Now, how do that JBoss instance know about the management channel? It's the advertising guy who tells about these two channels. So the job of the advertisement channel is to simply shout in the mic that, hey, look here, there is a load balancing channel here, there is a management channel here. Whoever wants to get the request, please contact the management channel. So any server who actually wants to join, let's say JBoss instance 3 is something that you want to start fresh. Now when you're starting the JBoss instance 3, all that you have to make sure is just make sure the instance 3 also listens on the same multicast IP port. And onto this multicast IP port, the advertisement channel is advertising about the IP port of load balancing channel and management. So the JBoss instance 3 immediately knows about the management channel. It then contacts the management channel. Alright, the management channel informs the load balancing channel, hey, there is a new guy, third instance, please start load balancing to the third instance also. The same way, the application status also is given to the management channel. Let's say while this is happening, the application on JBoss instance 1 went down. Because it went down, the mod cluster component of this instance will let this management channel know that, yeah, the instance is up, but the application is down. Now the same information will be passed by the management channel to the load balancing channel. The load balancing channel will stop sending the request to the JBoss instance 1. Now remember here, the JBoss instance is up. It's the application on JBoss instance that is down. So even if the app is down, the mod cluster will still be able to realize that the app is down and stop sending any request to that instance. Now how this is being possible? We have the mod cluster on both sides. So there is a mod cluster on Apache side, then there is a mod cluster on JBoss side also. So the mod cluster component on JBoss side actually sends all this information to the management channel, and the management channel keeps updating the load balancing channel. Now the job of advertisement channel is to simply shout on the same multicast address about these two guys. That is the architecture. Now once you have this one, let's look at the third diagram. That is the final diagram. I think I have taken the last one first. So here. So advertisement channel, load balancing channel, management channel. JBoss instance 1, JBoss instance 2. So JBoss instance 1 and 2 will listen on this one. Now the advertisement channel advertises about these two onto this one. Then what they do? They will pass the information to the management channel. Management channel informs about these two instances to the load balance. So when a new instance is added, that instance also listens on the same multicast IP port. The instance will know about the new management channel. It will send the information to the management channel. Management channel will send it to the load balance. Alright, so this is the overall architecture of the mod cluster. The important thing is you have three channels: advertisement channel, load balancing channel, management channel. If you see the IP ports, the Apache, you have to make sure it's listening on two different ports. One port is for the regular incoming request, the user request. The other port, 6060, will be used by the JBoss instances to send any information to the management channel. Alright. Now these are some of the points about the mod cluster again. The mod cluster is actually already part of JBoss. Now if you want to show that thing, let's go ahead and see what it is. So let's go to student JBoss RTP 101. JP1 standalone configuration. Let's check in HA profile because this is for cluster. We search for mod cluster. See this one? The mod cluster is already added by default into JBoss. You can actually see at multiple locations. See this one? Subsystem, mod cluster subsystem, connector, AZP connector. This is the load balancing method. It's not a round robin based load balancing. It is business based load balancing. Apart from this, if you search further, it will also give you the multicast IP port for mod cluster. See, there are three different mod clusters. The mod cluster IP port is different from JGroup's IP port, which is different from InfiniSpan IP port. So everything is different. So here, this is different from what we have seen on JGroups. This is for exclusively for mod cluster communication. So when we start the server, we will also see this 224.01.10, 105. So what I'm going to do is to set up this thing. Before we go again, when we start the JBoss using HA profile, it starts the mod cluster because just now we have seen the mod cluster is already in the HA profile. This is what the code of the mod cluster that is embedded into the JBoss. This can be seen in the standalone HA. Will be used by the JBoss server for listening to the incoming advertisement requests. Basically, the standalone HA profile has all the configuration settings of the mod cluster which are already there. So all that you have to do is you start the JBoss server using HA profile. The mod cluster related part is done for JBoss. You are left with doing the mod cluster setup on the Apache side only. Now let's go ahead and do that configuration. Now again, when you're configuring, these are the outlines. We'll get into in depth of it. The outline is we have to build the mod cluster. Mod cluster is open source, so we have to build the mod cluster related SO files. Now the difference here is mod cluster, there is no file called mod cluster.so. Normally when you have proxy plugin, you have mod proxy.so, then you have mod jk.so, but there is nothing like mod cluster.so. This is a common but you might get into trouble. So it's nothing like mod cluster. Instead of a single file, there are 4 shared objects. So we have to build all the 4 shared objects. The 4 shared objects together will represent the mod cluster. Now we will see how to build all those 4 shared objects. Now once you have built the shared objects, you have to copy all of them obviously into the Apache Home Modules directory. Then just like mod jk, we will create a special file for mod cluster. Let's call that file modcluster.conf file, and we include all the parameters related to mod cluster into this file. And once we have created this file, we're going to add that file to our main Apache configuration file, httpd.conf file. But there is one change that we need to do to Apache is we have to make sure Apache listens on 2 different ports. One port is for incoming requests and management GUI. The other port is for the management channels. So what we are going to do in summary is we will first build the .so files. Then we create all the settings related to mod cluster in a file called modcluster.conf file. Then we'll include that file into the main file of Apache, and you are about to start Apache server. Before you start Apache server, you make sure it's listening on two different ports. Now I will follow that document that we already have for this one. So the Apache installation will be using the same Apache installation. Let's say we'll be following this mod cluster configuration. The prerequisites, as usual, the Apache server should already be installed. We have already the Apache server, so I'm following the first prerequisite. So what we can do is use the existing Apache server that we have already used for mod JK. Now instead of mod JK, so let's go to the Apache server home. Let's go to the Apache server home. One minute guys, just give me a moment. Okay, let's go to Apache server. Now this is the Apache server we already have. So the Apache configuration and make command, make install, everything is same. Now if you remember, we have configured the mod JK for it, and this is our mod JK configuration file which we have included into the Apache configuration file. So if you have to remove the mod JK, all that you have to do is comment the mod JK related entry inside this file. That is the beauty of having a separate file for individual configuration. Now if you want to remove everything related to mod JK, all that you have to do is open up this file. You see this one? This is where we include everything related to mod JK. So I'm simply commenting it. Okay, just comment it. That's it. Your Apache is clean now without mod JK. Nothing related to mod JK will be loaded because we have commented out. Now instead of mod JK, we will be including a file related to mod cluster, which we will be creating in a moment. So our Apache server is ready. We will be using the same Apache server as usual. Just make sure the mod JK related thing is commented. Now the second point here is the important point, as we already talked about. The file name or the .so is not mod underscore cluster. It has 4 different .so files. These are those file names. The advertisement channel is represented by mod underscore advertise.so. The load balancing channel is represented by mod underscore proxy underscore cluster.so. The management channel is represented by mod underscore manager.so. The slot mem is basically related to the proxy cluster itself. So these are the 4 .so files that we have to build. Once we have built these 4 .so files, we just have to include them into a file and put that file into the main httpd.conf file. The configuration is simple. Alright, so let's go ahead and first build it. Now to do that building and configuration, we'll be following the high level summary steps listed here. Now following these steps make it simple for us. So step one, we're going to bring the source code from somewhere to this machine. If you have a stage server, the stage server has the code, so bring it from the stage server. Or if you have a clone, the clone already has this code in it. Alright, use it. Now once you have it, you're going to build the 4.so files. Alright, once you build it, you're going to put all of them into the modules directory. Then you will create a file called mod_cluster.conf file, and inside that file you set up all the mod cluster related parameters. We will see what are those parameters. These are the 3 parameters related that you will be putting under mod cluster file. We will see what is the purpose of each one of them. Then you will include that configuration file in httpd.conf file. And finally, step 5, you will start the Apache server on 2 different ports. So let's go ahead and implement the 5 steps. All right. Now the mod cluster thing, first of all, I'm going to copy it into this directory. It will be under JBoss related files or Apache related files, one of these 2 things. This is for mod cluster. This is the zzip file that you will get. So I'm going to copy. Now let's say where we got this file. You got this file from the net, guys. See, mod cluster is open source, so all that you have to do is download mod cluster or mod cluster source code. Alright, you go to the GitHub and download the mod cluster. Alright, now when you download the mod cluster, so say after you download the mod cluster, this is the file you would ideally get. Alright, I think in your documents you were given mod_cluster.zip. You will have this file in your clone. Now whereas here we have something is wrong. This is 126. We don't want this. It's supposed to be 129. Let me search for that file. Something is not correct. So the mod jk, this should be the new file. Yep, here we go. This is the file we are looking for. This is a file. I'm going to copy this file into our directory, home and code IT. The original file 126 was not actual file. This is actual file. So whereas in your case you will have mod_cluster.zip file. Here it's 129.final. I think this was downloaded from your net. You will have somewhere here. If you look in one of these things, source, you should see that 129. So, not this one. Okay, you just have to search on the net. Don't worry about it. I've already downloaded it. Start using it. So I'm going to now copy this file into our directory, students JBoss ITP 101. That's it. We have the file copied to our directory. That's good. Alright, this is the file. I'm going to create a separate directory for it, just like mod jk we have mkdir mod cluster. So move this 129 into mod cluster. Now we have the files. So let's get into here. Let's build our 4.so files. Now before we do that, unzip it. 1.2.9. That's a zip file, by the way. So when you unzip it, this is what you will get. Mod underscore cluster hyphen 129 final. Now go ahead, get into that directory. Now we'll follow the same process as the mod JK. You have to get into native and you will find 4 directories for 4 .so files. Advertise, mod proxy cluster, mod manager, and mod slot map. Now you have to get into each one of them, build the .so file just like the mod JK. Now the steps are again given here. Alright, the first thing you're going to do is cd to native. These are the 4 directories that you're looking at. Alright, mod slot map, mod proxy cluster, mod manager, advertise. We have to build all the 4 files. Alright, now let's start with the advertise.so file. So go into the advertise directory, run the build conf file, then configure it using this Apache home, then make. Now here in mod JK you have run make install also, whereas here do not run the make install. So you have to copy, at this step itself the .so file gets created. All that we have to do is we have to manually copy this .so file to the Apache home. Alright, see, remember Apache is a prerequisite for building these things because you will be telling where the Apache home is using this directory. See this one, this is Apache home, Apache APXS command, Apache portable extensions command. Alright, so Apache should already be there. If you don't have Apache, it will throw out an error saying that there is no web server installed on this one. So make sure your Apache is already there. So these are the 4 steps that we're going to perform, and this is how they look like when you run it. So let's go ahead and finish these things. The paths may be slightly different than what you are seeing here, so make sure you change the paths according to your environment. So the first thing I'm doing is build in the advertisement channel. Alright, so this is the build config thing. Run it, build config. In mod JK this name is build config.sh, whereas here it's just build config. So go ahead and build the config. So building config is done. The next step is to configure it. So I'm going to configure it with APXS. So configure. So when you said build config, it should have build the configuration file. You see this one? Here it is. Earlier there was no config file. Now you have config file. Now you're going to say configure -- with APXS. Now give the location of our APXS command in our Apache server. So let's open another session here. So let's go to the location where we have our Apache server. So under students, cd JBoss ITP101 that we have. Alright, this is where we have our Apache server. I have already commented the mod JK related entry in httpd.conf of Apache. So Apache is actually empty now. Now this under the bin directory we have APXS command. This is what we're going to use. So this is going to be our Apache /APXS. Alright, and so APXS support is true. Configure, it's creating this thing. Basically it created a make file. So the make file is created. Now your last step in this document. The last step is just make command. Do not run the make install, so just the make command. Run make command, enter. Alright, so your .so file is ready. At the end it will basically tell you remember to run libtool finish this thing, so don't worry about it. Just run ls-ltr and you have this mod advertise.so file. Now once you have this file, copy this file into the Apache home modules directory. enter. The Apache home modules directory is here. We'll take it from the same Apache home. This is our Apache bin. So enter modules directory. So you have the mod underscore advertise.so file created and being copied to the modules directory of Apache. So first module, you're done. Now go ahead and quickly finish the same set of steps for other things also. This is a copy step. So this is copied here. Now repeat the same 4 steps for the remaining 3 modules. We're going to go by this order. We'll first finish mod proxy cluster, then we'll finish mod slot mem, then we'll finish mod manager. Now the steps are already given here. Just make sure you follow it. So I'm going to go ahead and finish those things. Okay, advertise we are done. Now let's go ahead and do it for mod proxy cluster. Enter. The same stuff again. Build conf. Alright. Then configure it. The same command I'm going to use again. Copy paste. Make. That's it. Now I need to LSF and LTR. You have this proxy plugin. Copy this into the Apache home modules directory, which is this modules. Alright, copied. Now let's go ahead and finish it for the third module. So we're done with advertise, we're done with mod proxy cluster. Let's go ahead with mod slot mem. I think that mod slot mem, the third one. Yeah, let's go ahead with mod slot mem. Mod slot mem. Now you don't have the .so file yet. You'll get it when you execute the 3. So build config. Now again the configure command is same. Configure with APXS. So go ahead and finish it. Make it. It'll be done. Now the .so file will be ready. This. Copy it into the Apache home. Here it's given. That's nice. So modules direction. So slot mem is done. Now the last one. What's the last one? You got the mod manager. So get in there. Again, you don't have the .so file yet. So build config. Alright. Then configure. Go back a little bit. Copy paste that configure command. You can do this one or you can run it in the history command. So if you run the history command, you'll find it in the history command. Run it. Then make it. You're good. Now the .so file should be ready. This is a .so file. Copy this file into the modules directory of Apache. Alright. So all the 4 .so files ready. Now let's go to the Apache home. I'm just again copy pasting the same directory, Apache home. Enter. Now you are in Apache home. So this one. This is our Apache home modules. Now these are the 4 files that we have copied just now. You can see it by the timestamps. December 16th, they are copied just now. Alright. So once the .so files are ready, let's go back and see the summary steps here. Alright. Build the 4 .so files and copy the .so files into Apache home. Now create a mod cluster.conf file and set up the mod cluster related parameters in it. Step 3. Now you can see those steps in here also. Create a file mod cluster.conf file and set up the mod cluster related parameters in it. So let's go ahead and finish that step. Let's see how to do that. This is what we are trying to do. So this one. I think it's already included. It basically finishes step 5 first and then comes to the previous step. Means it sets up two listen addresses for the Apache server, and then it includes that file and then talks about creating that file. Either way, it's okay. So let's go ahead with B step first. So I'm going to go ahead with step B first. So just like mod JK, we are creating a file for mod cluster. So let's just touch that file, mod cluster.conf file. Touch command will simply create a file. That's it. It will not put anything. Now you can open that file and set up these things. Now obviously the first things are to include the .so files. So I'm going to include it. Now when you're including, you may not be able to copy paste it, so make sure you type them properly. So that's load module, advertise module you are including, proxy cluster module you are including, slot mem module you are including, manager module you are including, and these are the locations, which means before we do any of these things, the .so files should already be there in Apache home modules directory. Alright, so once you have included the modules, we have to divide the traffic. Now the incoming traffic either will be for 5050 or it will be for the 6666, which means we have opened two ports. If you hear, I think 5050 and 6060. It cannot be 6666. So whatever ports you have opened, you have to define how those ports are going to be used. Now that is usually done by creating a virtual host, because there are two port numbers. We have to define what or how each one of those ports is going to be used. First thing, we are telling how any request that lands on 5050 port will be handled. You will define it by creating a directory. Say this one, if the request comes from root directory, allow from this segment. If the request is for management channel, the mod cluster manager will handle it and allow. Just make sure you copy paste these things. And again, if it is coming for 6060, the server advertise channel is this thing. Means the advertisement channel is listening on 6060. We have to enable the MCPM receive protocol. The MCMP, there is a protocol name for it. I'm not sure if I remember it. MCMP protocol. This is basically a multicasting protocol. Yeah, mod cluster discovery protocol it's called. MCMP means there is something. Yeah, see this one, mod cluster management protocol. Again, that's a fancy name for it. Just remember MCMP, MCPM, sorry, mod cluster management protocol, isn't it? It's supposed to be MCM receive. MCMP. The setting, I think it's wrong, or usually you have this copy pasted from one location to other location. Yeah, MCPM receive only. This is correct. But the protocol is MCMP. So the parameter is different, the protocol is different. Alright, so what we are about to do is we're going to copy paste these two virtual host related things also. You will be usually given a file, text file with all these things. So if you're not able to copy paste from your PDF, so make sure you copy paste it from the text file. So I'm gonna put it here. What? Deny all. Okay. The formatting is a little clumsy. Let's do a little formatting. So that's for virtual host 1. Do the same thing for virtual host 2. Be very careful when you're setting up these things. Even a slight typo may make your server not work at all. So be very careful when you're doing these things. Do not include any additional characters into this one. So if you see that the servers are not working for some reason, come back and revisit these steps that you have done. I see. Okay. That seems okay now. Now, just remember one thing, that we want to enable 5050 and 6666 ports, or let's say 5050 and 6060 for the sake of these things. Virtual host, we will talk about it in a moment. Virtual host, for now, just remember that you are making Apache server listen on two different port numbers, 5050, 6060. So the sender of the request means when a process sends a request, they might send on this IP port or they might send on this IP port. Both the requests for both the ports will be handled by the same Apache server, but the sender does not know it. The sender thinks that they are sending it to two different processes, whereas here it's a single process. Because of that reason, each one of these are called a virtual host. This is not actual host, it's virtual. But the sender thinks that each one of them is different, whereas they're all handled by a single Apache server. We will talk about that in detail. So here, if this is 6060, we have to change this one also to be 6060. So 6060. I'm not sure why this was given a 6666. Alright, let's do one thing. For now, keep it 6666 only. The server advertisement channel is... Okay, we'll see that. Let's say 6060. So your file is ready. Now these settings, everything, you will be able to copy paste it from the notepad. I'll set up a notepad and give it to you. Alright, let's see. Let's do it now itself. It'll be easy to copy paste it. Mod cluster.conf. Okay, I'll transfer that file anyway. So this is a different thing. This is a different thing. I'll be able to copy paste this. And this is a second virtual host with its own directories. Now make sure whatever port you are using here, the same port is being used here also. Alright. So let's go ahead and finish the remaining. So you have created a mod cluster.conf file. So that is step B. Now let's go back to step A. Step A is to configure your Apache server with this newly created file. So first of all, we will make sure the Apache server is listening on two different ports, 5050 and 6060 is what we are using. So this document says 6666, but it still shows 6060. Make sure you use the same thing. Always use 6060. So I'm using 6060. So let's open up that file, httpd.conf file. Look at the listen thing. So instead of only one listen, we're going to have one more. So 5050 6060 also. Alright, that's our step 1. So open HTTP, set up these two things. Then log level we're going to set up to debug, just in case if you have any problems, so we might know it. So search for log level, come down, search for log level. You can do a search, otherwise just browse through it. Come down and see where you have log level. Yep, here you have it set up to warning, so I'm going to comment it, create a new line, set up to debug. Possible options are available here. You can set it up to any of these things. Debug is the least level, means you will see everything. Now after log level is debug, then server name is another parameter that you want to set up. So come down further. Maybe the server name is already above. Let's go to the above. Let's go to the beginning of this log file. So this is the beginning of the log file. Again, come down. So come down further. Look for server name here. Here we go. It's already there, so we don't have to really do that, because this was done for mod JK. So you may keep the IP port or you may remove it. Either way, it's okay. Because we have two ports, so let's say we remove it. So we only give only the IP. Okay. Now finally include that file that we have into this httpd.conf file using this command. Already we had this JK. I have commented this one, included this one. So the same setup we're going to do again. So come down where you have all the include statements. That would be towards the end of this file. To the end of the file. So here we go. This is included. So I'm going to it's already commented. So I'm going to copy paste that line and httpd-jk instead of that. Our file is mod_cluster.conf file. So we have just included it. Save it, close it. You're ready. Alright, this step we have already finished. So we have added this. Alright, now start the Apache server using this thing. So let's go ahead and start the Apache server. Now before we go that, let's check the syntax. Apache CTL-T. Syntax seems to be okay. Before we start, make sure to check nothing is running related to HTTPD. So Apache CTL start. Now check it. Grab HTTPD. Now they are started for 6 process. They started at 2118. Right. Now let's go to the log files and make sure there are no errors in the logs either. Error underscore log. Go towards the end of it. It seems like the mod cluster is loaded. You see this debug. This is the reason for that debug. Shows you everything. So looks like things are okay. I don't see any errors during the startups. So the mod cluster. Okay, now let's check the ports also. 5050666060. netstat-na grep 5050. It's running. netstat-na grep 6060. It's also running. If you want to see which process is using that port, you can always use this netstat-nap grep for 5050. This is actually being used by 22320, which is actually our HTTPD process. You see this thing? This is our Apache server. Now the same thing you can do for 6060 also. That will also be the same process. So means the same process ID 2230 is actually using port number 5050 and 6060 also. Alright, a 6060 is the advertisement and the management channel. That's where all the JBoss instances will try to send that information. Now let's go ahead and start the JBoss cluster. Or we are simply starting the JBoss 2 instances like our mod JK itself using the Asia profile. So let's go to that location, JBoss JB1. So bin directory. I'm starting 2 standalone servers. Start server 1. See this one? This is with the Asia profile. This is the lesson address for regular ports, lesson address for these things. We are calling this a server 1 instance. The log file will go into server 1. The same way, if you do the second server, everything same except we have a port offset 100. The name of the server is going to be 2. Alright. So let's start both servers. Start server 1.sh. You can do server 1.log file. So it's coming up. Application is already deployed, the clustered application. This var file is already in your clone. Even if this var file does not exist, you can still test the mod JK. Mod JK simply creates the load balancing. Right. So this is up. Now the same way, let's go ahead and start the second server also. Start server 2. Look at the log file, make sure it's also up without any issues. Server 2 is up. Right. This is up. Now we're good to go. So our JBoss instances are running. These are the 2 JBoss instances. Alright. We did not change the Java home. We should have changed it. Go to standalone.conf file and change the Java home if you don't want the default one. Alright, but for now it should be okay. Now we can actually see the mod cluster multicast address. netstat-na DLS. You will see 2 multicast address in that 224 range. So I'm coming down further. Look for 224 and above series. Here we go. This is the J groups. JGroups you will see only if you have deployed a clusterable application. So this is for JGroups communication, and here we go. This is for mod cluster communication. All right. So this is already into this multicast. Any newly added JBoss instance will start sending or receiving messages, and into the same IP port, even the advertisement channel starts sending the requests. All right. So that's also up. Now we are actually up. We have actually started the JBoss servers, and actually the Apache server is also running. You're good. Your setup is done. Now the next thing is to test it. Now obviously the testing, you will have to send the request to the Apache server, check whether it's balancing it or not. Now all those statistics can be accessed by using the mod cluster management channel GUI. So we can access the GUI of the mod cluster management channel by using IP port of Apache/MC. So let's go ahead and do the mod cluster thing. All right, here we go. All right. So you can actually see the context. See, this is the application. What's the status of this application? It's enabled. That's for virtual host 1. You can, this is for node 1 and node 2. See, this is one node. This is another node. We have actually the AZP protocol, this one and this one. So we did not even tell about the AZP protocol. In mod JK, we actually tell where the IP port of AZP protocol instance is. Whereas in mod cluster, we don't tell it. When we start the JBoss side mod cluster component will advertise all these things to the mod cluster side of Apache. So the mod cluster automatically detects it. So if you start a third server now, you will see the third server also here. So for now, let's first see if the mod cluster is able to do all the things that it is doing it or not. Now let's first look at what it is. So it was, don't worry about the aliases. Let's look at the status of the application is enabled here. All right, this is also enabled here. So we are ready to send the request. You can actually select here. Now we are going to monitor this. All right, it will basically tell how many times this node was selected. Now when you start sending the request, you will see this was elected 0 times, this was elected 0 times. Let's send the first request. Now before we send the first request, let's try to access that request on JBoss directly. 192.168.128.6 8080 slash, this is HTTP, so encode IT, I'm not sure. This is the URL. What's the URL? Clustered app, is it? Yep. So this is the context. So we are able to access it on JBoss server 1. Now let's try to access it on JBoss server 2. See, remember this is not AZP, this is HTTP. So we're just making sure the app is available on both the servers. That can be actually found out here itself. The app is enabled here, the app is enabled here also. Now both of them is available. Now let's send the same request to Apache server. Our Apache is listening on 5050. Remember, both MC and regular requests are sent on the same thing. Means your mod cluster GUI and the general request will be coming on 5050 only. 6060 port is used internally by the JBoss instances. So now when you send it, it will go to one of the JBoss instances. Which one we can see on the status here. Now if you see here, refresh this page, nothing we can see. Elected is not coming. Let's change. Let's try to send a couple of requests. Just create it. Yep, here we see. 3 requests here, 2 here. I send one more. Refresh this page. It's taking a little time to update this one. Now 4 and 2. Send one more. Just refresh this page. Come back here. Reload 5 and 2. Go back. Refresh here. Reload 6 and 2. Alright. Now see, this is not a round robin. It's more of a load. Now the load is actually identified by a number. Here if you see 100 is no load, means both are equally load. If the number reduces, it means it's more loaded. So the request will go to the JBoss instance which has higher number. Higher number means less load. So what I'm going to do is I'm going to simulate some load using the while loop that we already have. Alright, so I think I have given that while loop already in here. So let's go ahead and run this while loop. Alright, I think this needs to be changed if you are using the cluster, this thing. So I'm going to go ahead and run a while loop with this URL. /temp. The temp directory is gone, so let's create mkdir temp cd temp. Alright, while true, do this thing, sleep for 1 second, and you're done. So this keeps ups, no such file or directory. We missed the wget part. So while true, do wget, then this URL and sleep, done. Okay, now just make sure you are getting 200 here. It means it's successful. So you are receiving a lot of load. You can actually see this. Now refresh this page, keep refreshing this page. You will see the load getting distributed. 12, 7, 15, 10, 16, 11, 18, 12. I'm reading these two numbers, guys. 20, 15, 22, 17, reload, 24, 19, 26, 20. So the load is getting distributed. Now because these requests are small requests, the load factor is not changing. It may happen that some of the requests which reached here takes longer than the request which reached here. In that case, the load number will be reduced. Once the load number comes down, this will be elected less number of times. Means if this number is low, it means do not send me the request, I'm overloaded. Alright, so that's your first thing. So your mod JK is actually distributing the requests. Now what we want to do is we want to check the first thing, the dynamic cluster. Means if one of these nodes goes down and comes back up, will the JBoss server automatically detect it or not? So I'm going to kill one of these JBoss nodes now. Alright, so ps-ef grep Java. I'm going to kill the node 1, let's say. Server 1 I'm killing. Alright, kill it, kill -9, shift insert, ps-ef grep Java. So there's only one running now. Let's go back and see it. Let's see the status. Reload. This status is still enabled on both of them. So this one here, here's a problem. The status is not okay. Here the status is okay. So this election will stop now. Means it will not move beyond 70 anymore because the request will not be sent anymore. So this is 70, but whereas this keeps increasing. 97, then 70, 102. Reload. 70, 107. So now the requests are only going to the OK status one. Now let's go ahead and bring it up. When you bring it up, the mod JK automatically detects that it was brought up. So go ahead and start the server. JBoss ITP101 JB1. Let's start the first server. Bin directory start server 1.sh tail-wf server 1.log. Now the server is up. Now let's go to that. Now we are checking this one. I'm going to reload it and check if the status changed or not. Reload. Still the same. Reload it again. Now it's changed. Now once the status is okay, the 70 number keeps changing now. So reload it. Now you see. Means when the request or when the status is not okay, the request will not be sent. This will not be selected or elected. It's more of. Alright. When it is up again, the mod cluster dynamically detects it and starts sending the request. Now look at the beautiful part. We have only 2 servers. Now everything is running smooth. Now let's say we thought we want to add one more server. Now without disturbing any of these things, we can actually add one more server. So what I'm going to do now is I'm going to start a 3rd server. Alright, we have already 2 servers up and running. Alright, that is server 1 and server 2. I'm going to start server 3 with a different port offset. Let's say I set 200 offset. So I'm simply going to copy this thing. Server 2 to server 3. .sh. Modify the 3rd one and start it off. The profile will remain same. The binding address. The port offset is going to be 200 this time. Node name is going to be server 3. The log file is going to be server 3. Go ahead and start server 3. Now start server 3. So we are simply adding a 3rd node to our cluster, which means the mod cluster has to automatically detect it and start sending the request to the newly added server. So just make sure the server is up now. It's getting a little slow. Server is up. Now again you are back to this one. Reload it. You should see a 3rd node, guys. This is 801. Here we go. Which means without disturbing any of these things, we have started a 3rd server. So elect it. Alright, now you can actually, so a server is added and it's also getting the load. Now you can add a 4th server also. It's a little bit extreme, but let's go ahead and do it. So that's a dynamic cluster, guys, the most beautiful thing. I go ahead and start the 4th server. See, this got slow now. Now offset make it to 300 this time. Let's call this node server 4. The log file for this one is going to be server 4. Good to go. Start the fourth server. Let's assume it will come up. So 8309 will be what you will see. Reload it again. 8009, 8209. It's not coming up. It's not detecting. Mod cluster JBoss JVM root. It did come up. We want to see 8309, the fourth server to this cluster. Yeah, here we go. Now go on adding it. You can add as many servers as you want. They will be automatically detected. Now if you kill any of them and restart it, it automatically gets detected by the JBoss module. Now that's one thing. So let's look at the other features of mod cluster. We said dynamic cluster, we tested it. AJP, HTTP support, that's okay. Business-based load balancing is another thing. Business-based means we have to be able to change this business. Means we need different kinds of requests. At this point, we don't have different kinds of requests, so we cannot keep one server busy while the other is free. So let's say we cannot test it now. We can test another element. If the application on one of these things is down, now how we're going to handle it? So we should shut down the application on one of the servers while the server is still up. That is another this thing. Now that is a problem here because see, our application is in a single deployments directory. All our servers are from the same installation. If you have different installations, then you can actually delete the application from one of the installations and simulate such a thing. But here, if we remove it, okay. If we remove it, actually the status of the application will be down on all the instances. So this one, status will be disabled. But in if there are multiple different installations, they will be disabled on one and enabled on some other. Now let's try to actually disable this one. Let's go ahead and disable on all of them. At least we will see whether it's detecting the failure of the application or not. Means the instance will be up, but the application is down. That scenario also your mod cluster should be able to detect. So here I have removed everything, so nothing is there. Now if you refresh this page, yeah, I think so everything changed. Is it? The status of the application is not there at all. It's down. In that case, basically everything is a problem. So the load is actually getting distributed across all the destinations, but the context is not available on any of them. Alright, now let's go ahead and deploy it because all the servers are using the same var file. I'm going to copy this var file. It's just here. You can copy it from anywhere you want. So it's getting deployed. It gets deployed once you copy it. You can actually see from the marker files. So this got deployed. So let's refresh this page. It's detected. So the mod cluster actually detects not just the instance availability, it also can detect the application availability also. That's the beauty of mod cluster. So these are four important things. Dynamic cluster, we checked it. Application status report, we checked it. AJP or HTTPS, both it can support. Load factor, we were not able to check because the request types should be different. We have only one type of request. We are asking for HTML page, so we cannot keep one server busy while the other is working. If you have such an application, even that's also possible. So that's your beautiful mod cluster. I hope you enjoyed this session. It's a really nice one. So if you are able to explain the architecture and how this works, it's really nice. All right. So apart from this, there are a couple of other things that we'll talk about, especially the proxies, forward proxy, reverse proxy, and we'll talk a little bit about virtual hosts, and that will be our advanced JBoss in our next session. All right. And we also have the mod proxy thing, so that also we'll see. If you've already done, that's okay. Otherwise, we'll see that one also. Right. That's all for now. See you on the next session.